Okay, so in this problem, I'm given a bowling ball on a slope that's attached to the slope with a rope. I'm given the angle that the slope is elevated from the horizontal, and I'm given the angle that the rope is elevated from the horizontal. And I'm also given the mass of the bowling ball. And the question is, if this bowling ball is static and not moving, what is the tension force that is keeping this from moving? So the first thing I'm going to want to do is make a free body diagram, and I'll represent the center of mass of the bowling ball just with this little dot. First force I'm going to put down is force due to gravity. That is completely in the y direction, and I'm going to call that mg. Now the next force I'm going to put down is the tension force, which I know is at 45-degree angle. So I'll do this, call this T, and I'll just denote the horizontal like this, and this is 45 degrees as it was given to me in the problem statement. Now, the other force is going to be the normal force. So what is the angle that the normal force is going to be at? Well, theta here is given to be 45 degrees. So I can draw a line perpendicular through the center of mass to the slope. And if I do that, I can use the alternate interior angle theorem. So it looks something like this. Slope, and then here's center of mass, the normal force. This is 45 degrees, so this also has to be 45 degrees. So I'll draw this here, call it N for normal force, and this is at 45 degrees. Okay, now that we have all our forces listed in our free body diagram, we want to write out some relations we know about the forces and see if we can solve for T. So the first thing that comes to my mind is that this bowling ball is static, so that means that the sum of all the forces has to be equal to 0. So what I want to do now is add all these forces together and set them equal to 0. So it'll look something like this. Sum of all forces is going to be equal to 0. Now since this is stationary in the x and y direction, it's a good idea for me to decompose this into its components and then set those equal to 0. So that will be sum of forces in the x direction is equal to 0. Sum of forces in the y direction is equal to 0. Okay? So now what we need to do is write these out and decompose them into their proper components. So let's start with sum of forces in the x direction. Okay? So the force due to gravity does not have any components in the x direction, but the normal force does. So what is the x component of the normal force? Well, if you use some trig, you can see that the cosine of 45 times the normal force will give you its x component. So that will be N cosine 45. Okay? Now for the tension. The tension is also at a 45-degree angle, so we can use cosine for it again as well, but it is in the negative x direction. So we will subtract T cosine 45 degrees. This is equal to 0. Now for the y direction. So gravity pops out. It's only in the y direction. We'll write this down. It's in the negative direction because we defined that to be positive. So I'll write down negative mg. We don't have to decompose anything with it because it is completely in the y direction. Now for the normal force, how do we decompose that into the y direction? Well, we can use trig again, and we can say that the sine of 45 times the normal force will give us its y component. And that's going to be positive as it's in the upward direction. So that will be N sine 45 degrees. Now for the tension, it's going to be the same exact thing, and this time since it's in the positive upward direction, we don't have to mess with the sign at all. So this is plus T sine 45. That's also equal to 0. Okay, now that these are both equal to 0, we can set them equal to each other and try to solve for T. So we will have N cosine 45 degrees minus T cosine 45 degrees equals negative mg plus N sine 45 degrees plus T sine 45 degrees. Okay, so 45 degrees is one of the angles that we have a pretty well-known trig identity for. So if you remember, it'll be something like this. You have your 90-degree angle, 45, 45. So a 45, 45, 90 triangle has 1, 1, square root of 2. So the cosine of 45 will be the adjacent over the hypotenuse. So it'll be 1 over the square root of 2 Sign will be the same exact thing since this is 1 as well. So I can rewrite this as n divided by square root of 2, because it's 1 over the square root of 2 minus t over the square root of 2 equals negative mg plus n over the square root of 2 plus t over square root of 2. Okay, so now what I want to do is isolate t on one side and get everything else on the other. So I will add t here and then move the rest of this over here. So if I add t over the square root of 2, I'll get 2t over square root of 2. Now if I add mg over here, I just get mg. If I subtract n over square root of 2, this is positive n over square root of 2, so that becomes 0. So this is just plus 0. And now what I want to do is I'll multiply by square root of 2 and divide by 2 to get t by itself. So this will be root 2 mg over 2 equals t. Now if we use the mass that we're given, which is 1 kilogram, g, 9.8 meters per second squared, multiply that by root 2 and divide by 2, we will get t, which is a force, is going to be, it will be about 7 newtons in magnitude.